I want to quickly walk through this notebook to give you some background on how it works and how you might be able to reuse the observable ideas that are in here. This is a quite simple example of an observable based visualization. So there's a lot of stuff that I'm not illustrating. There's a lot more functionality under the hood, but this should give you a pretty decent head start. So as you won't be surprised, I'm using some COVID data to illustrate this. Here at the beginning, I've tried to link in some learning resources and reference information that you could click through to get more information on the various things that are being used in here and kind of for your own reference. The data that I'm using is the Johns Hopkins data that's much in the press these days. First thing to take a look at here is I want to go show you how this is structured out on GitHub. So the information here is split into several different categories. So there's daily reports from the WHO and so forth. But what I'm using in this example is this time series data. And they've arranged to kind of split the data up in several ways that make it easy for people to use in these types of visualizations. So the data are split by confirmed versus deaths, and then also recovered counts across the world. And then they've split those up further by the United States and then other countries, actually all countries including the United States. But the US files here have US data split up by county, I believe. We're going to focus on the global data, so it's information from all countries, and then and on the confirmed cases. But the other files are formatted in a similar fashion. And there's a little bit more detail about how this is all done here. So let's take a look at this confirmed global case. It loads up, and because the file is of sort of a modest size, GitHub recognizes that it's a CSV file and formats it pretty nicely as a table. And you can see there's multiple columns. There's kind of the province or state division, the country, and then latitude and longitude. And you can see for some countries like Algeria, there's no further distinction of states or provinces, but Australia is actually split up by the Australian states. So some of the data in here needs to be combined. Here, Canadian data is split up by provinces and so forth. The US data in this case is actually just one line. Here it is, US data. There's just one entry for it, but then there's those other CSV files that have details for US cases if you're interested in drilling down into more information. We're going to look at visualizing the data by country, which means that we've got some issues with this data set in that the countries, in some cases, but not all, of course, are split up by provinces or states. So one of the things that we're going to have to do is combine those things together to get them all under a single country. And then another thing is that the data itself is definitely not tidy. We can see that there's columns that actually have values across from the first recorded cases in January up through, in this case, the 26th, which is yesterday as I record this. So we're going to have to do some data tidying in order to be able to use this in the observable setting. One of the neat things that GitHub does for you is that you can access the raw data behind this by clicking on this raw button, and that just gives you the raw CSV information. And you can actually access this remotely. If you look up here at the URL, you can see that this is raw githubusercontent.com and then the path to this file. So if you're back here on sort of the normal GitHub page, just github.com, GitHub will take the liberty of formatting this information for you. But if you want to get at the raw data, you can just click raw and then use this URL instead. And that's actually the URL that we're going to use to load these files into our application. Okay, let's switch back here to the place where I'm loading this stuff in. I elected to create a function that I'm going to reuse several times to do the reading. And you can see that in the observable notebook, the fact that I've defined a function elsewhere in the file is indicated by this underline. You can also see over here on the side that there's this kind of neat visualization of the structure of the notebook that includes connections between things that are defined in the notebook and then places where those things are used. So we can see if I click on this cell, that I can see that I'm using this read time series. It's abbreviated here a little bit, but if I click on read time series, it will actually take me to the definition of that function. And as is typical with observable notebooks, a lot of these kind of standard top-level definitions are just collected together into an appendix. Unlike a Jupyter notebook, there's no need to put things in the strict order down the page where you have to define things before you use them. Because Observable does dependency management between cells, it can figure out what needs to be evaluated before what other things. So defining this function here down at the bottom, read time series, works just fine. And this illustration here where we can see we're at this read time series cell, that one's highlighted here, and it shows us here on the right side of this little graph where that function is actually being used. It's up in the cell called raw data. We can click on that button and it'll take us to the cell that's making use of it. And that's true throughout here. So if I went to, for example, countries, I've got this list of country names that I'll use later, and you can see that that is used by this cell by just following that little link. And here's where the countries is actually used. And then again, the underlining always gives you an idea about where the other pieces and parts are located. So here I've got a data set called tidy. Here in the little visualization thing, I can see that that's defined up here in this cell. So that's just a really handy way to navigate around within your observable notebook. This read time series data, again, is bringing the information in from that raw GitHub page. So raw.githubusercontent.com, blah, blah, blah. So this is that whole path, except for at the very end, the files are all called time series COVID and then some name.csv. Because these are all the same file paths except for the actual name of the CSV file, I thought, well, let's just make it simple for us to load these things in, and we'll just define a little function that we pass in the file name or the portion of the file name that's necessary to fill that out, assign that to a constant called URL, and then we're using the D3 CSV method to fetch in this URL. So this is standard D3 stuff. It knows how to read comma-separated value files, and it takes as a first argument the URL or file name that it's going to access. So in this case, because we're giving it an actual HTTPS URL, D3 knows to make a connection across the internet, go and pull this data in from the GitHub site, and then return it. The other thing that we're using here is, as a second argument here, you can supply information to give the CSV method some hints about how to format the data as it's reading it in. And there's one function inside of D3 called autotype. And this looks at each of the fields that are being read in and tries to assign them to a reasonable type. So instead of them all coming in as strings, it's going to look at the content of those strings and go, oh, this is all numeric characters. Let's bring it in as an integer. Back up to this raw data cell. And we can see here that I'm bringing in the confirmed US, the deaths US, confirmed global, and deaths global. I'm only actually going to use the global confirmed information, but I thought I'd illustrate how to read in multiple things in the same cell. And this is all being assigned to the raw data variable, so that's what is exported here, and we can use it elsewhere. Some things to notice here is that because this is an object, right, it's an object that's got two properties, US and global, and each of those are in turn objects that have two properties. But at the top level here, if I were to take out these parentheses, the interpreter would think that I was trying to define a function, which I'm not. So putting the parentheses around it, I end up converting that into an expression, which just happens to contain an object. So this is a simple way to always force an object to come back. Notice also that I'm using await here because these function calls are returning a promise. So they're asynchronous because they're going out across the network. And if we go back down here to the definition, you can see that I'm just returning d3.csv. So whatever this thing returns is what's coming back from read time series. And what's coming back from this is a promise that will be resolved when the request is completed. And that allows us to use await here so that when each of these things completes, the await will allow the promise to resolve, and then it'll assign the resulting value to these properties within the data. So having read that data in from the GitHub site, I'm showing here how to print out the contents of that table. So raw data is the variable that was assigned from this cell. Raw data.global.confirmed is the information about the confirmed global cases, and then print table takes that information, basically a list of objects, and formats it as a table. And rather than print out the entire table, I'm just using the slice function on here that says slice out array elements 5 through 20 and display that information. So you kind of see here that we're successful in having read the data in. It looks reasonably formatted. It matches what was on their website, which is just a good sanity check here. Next in the file is a little support function that just checks to see if a string looks like it's formatted as a date. I should really probably move this down into the appendix section at the end. One of the things that I found with this data set was that when I read the values in using the D3 auto type function, it did not detect that this was a date. So it just brought it in as a string, and I'm going to have to deal with that a little bit later as I tidy the data. But this little isDate function is just a test to see if the string that you pass in matches a regular expression that looks like a date formatted in this fashion. I'm also bringing in a list of the countries involved because I'm going to want to visualize by country. And in this function is actually using a library that you may or may not be familiar with called Lodash. And I've got the Lodash homepage up here. Let me skip over to the documentation. It's got a very large collection of functions that allow you to do operations on arrays and objects and strings and collections and all sorts of things. And it's oriented toward doing functional programming. So it's a collection of really simple functions that do one job. They take a specific input and they generate a specific output. They have no side effects for the most part. So it's really easy to use to manipulate data in kind of a stream of invocations of these functions. Some of the functions in Lodash are a little bit duplicative with the native functions in JavaScript. There's a map function on an array in JavaScript that's a standard thing. Lodash has its own map function. It's just a little bit less clunky to invoke in some cases. So I'm going to make use of a fair number of the functions from that Lodash library. It was actually preceded by another library that's still out there called underscore. So a Lodash is the same thing as an underscore. And by convention, when you use this library, you assign it to just an underscore, which looks a little bit weird, but it's just an ordinary identifier that is in fact an underscore or a Lodash. So we're going to just call methods on this underscore variable. Looks strange, but it's a very common convention for the use of these two libraries. Here in the list countries function, I'm going to basically hand this one of these collections of time series data that I read in from the website. And what I want to do basically is find all of the unique values for the country and the region. So the body of this function is pretty straightforward. I'm taking the time series data, so the structure that I handed in, basically this thing, and then I'm running the standard map function. So here I'm using kind of a mixture of Lodash and the standard JavaScript things. But time series data, I'm going to run map on that. So it's going to basically hand each of the objects that are in this list of objects that were read in from GitHub, and it's going to call a function on them. And I've defined a function here that just says, given each of these objects, take that object and just grab the country/region element and then return that as the value. So what map does is it iterates over this time series data list or array, and for each of the elements in that array, it's going to call this function and return that as the value that it's going to then collect together in the result. So it's going to convert this time series data that's an array of objects with each of these fields in it, and it's just going to convert it to an array of the value of this country region column. So it's going to be an array of strings. Because there's multiple entries in here with the same country, I don't want that country to appear as many times as it appears originally in my list of countries. So I'm using the underscore unique function. So underscore, again, that's just this Lodash library that we're loading in. .unique takes as its argument a list, and it just makes sure that it only has unique values. It removes any redundant values. And then I'm calling on the resulting array the standard JavaScript sort function, so I get those countries in alphabetical order. You can see here then an invocation of this list countries function. So I'm calling list countries and pulling in again from that raw data that I read from across the web, raw data.global.confirmed. So it's basically these data here. and assigning that to countries. And then if you look at the value that comes back from this, it's an array of the 185 countries that are present in the data set. And you can see, of course, that I've only now got one Australia as I wanted, and they're in alphabetical order. Next thing I want to do is group the data together so that I can deal with this problem of multiple rows with the same country. And I'm going to use another Lodash function called group by. And what it does is it takes an array of objects, like our global confirmed data, and it's going to group them according to the second argument, which is a function that's going to be invoked on each of the elements in this array. So the array consists of these objects, and we're going to group them according to the country or region. The result of that then is going to be an object that is got as its key the value of this country region field. This function is basically saying go into each of those objects and fish out this particular property and use that as the thing to group with. So you can see here that we've got as the keys of this object the value of that country region field. And then what it's done is it's grouped together all of the instances of the original objects that have the same value for that key. So you can see here, if we drill into Australia, that we have an array consisting of 8 of the original objects, and because they all have a country region of Australia, that's why they're listed in this array, keyed by the country name. And for a lot of these, where there was only one entry here in the original data set, like say Argentina, if we look at Argentina, it's still showing up in this object, keyed by the name of the country, but if we drill into it, there's only one object inside of here that contains data from Argentina. So that's kind of the data that we're now going to be working with to try to tidy up in order to be able to visualize it more easily with Vega-Lite. We're going to reuse this idea of the group by to gather the data together by country inside of this block of code. And this is really the business end of the tidying up of the data. We can see that what we're going to end up with, let's just kind of start with the end in mind. I've got now 17,000 elements in this array, and you can see that they are simply the individual samples of the data from the original data set. So for a given country on a particular date, the count of confirmed cases is 0 for Afghanistan as of that day. So you can see we're reusing the country name. I've converted the string version of the date into an actual JavaScript date object and then retained the count as the value. So this now is a tidy data set that we can use to make the graphing a little bit easier. So how do we get from this to that? First of all, D3 includes this function called time parse that allows us to parse strings that have time data in them and turn them into an actual JavaScript date object. So you basically construct a time parser, or a date parser in this case, and you give it a format string that specifies the format of the data. So this says there's a month, a slash, a date, a slash, and a year. And this gives you back a function that you need to evaluate in order to be able to convert those dates. So this is just a little helper function that we're configuring inside of this block. The next piece here is going to aggregate that country data. Remember that we've got data of this format right now. We've got, by country, we've got a list that contains the objects from the original data set, but now they're grouped by country. And what we want to do is get the totals for each date for that country. So we've got to go through this portion of the object that has these date-like strings associated with them as keys and find the matching ones across all 8 of these objects in the case of Australia, and combine them together by just creating a sum of those values for a single date. And that's what this aggregate country does. It's going to take some country data, and that country data is basically going to be the information here in this list of objects. What it's going to do is create a map that's indexed by the date. Now, if you're not familiar with the map object, this is a standard JavaScript type that's basically a hash. You can map from a key to a value. So we've created a new map here called counts by date, and then we've got some loops going on here. And this is again using a function from Lodash that creates an iterator. So it works in a way that's kind of similar to the for each function in JavaScript, but I'm using the Lodash one instead. So these for eaches take 2 arguments. One is an array that we're going to iterate over, and that's going to be the individual rows of the data here. These guys in the raw data set. And the second argument is a function that's going to be called for each of the elements of that array. So record is going to basically be one of these rows, which contains some information about the particular state, but the part we're interested in really is the counts that are organized here by date. Every time we call this function, we're going to have a new object being passed from that original list of country data. Inside of that function, we're going to do a for each again. We want to iterate over all of the key value pairs in this object and find the ones that look like they might be dates, in other words, the ones that match that regular expression that we looked at before, and then use that to extract the count for that particular date. So back to our function, inside of here, we're going to get a record, which is this entire object. And because we're iterating over an object, what Lodash will do is give us access to the value of each of the properties, the key for each of the properties, and there's actually a third argument that gives us the object itself, but we're only going to use those first two. So in terms of our original data set that has these key value pairs, for the entries in that object that relate to data for a particular date, they're going to have a value that's an integer and a key that looks like a date string. The for each is going to invoke this function for each of those records. We want to skip over the ones that have province and country information in Latin lon. We're going to use that isDate function that's going to take the key, which in most of the entries in this object is going to be those date values, and we're going to check to see if it does match that regular expression that we defined before that tells us that this looks like a date. If it doesn't, we're just going to ignore it. If it does, then we've got one of two possibilities. Either we've seen this date before or we haven't. That makes a difference because of the way we have to access this map object. One of the methods defined in the map object is has, and it basically says, does this map have a key with this value? And so the first time that we encounter a specific date, we will not have added that to the map yet. So we would take the else clause here. We don't see that key. So what we're going to do is we're going to set the value in that map under this particular key, that date string, and we're going to initialize it to the value of that particular property. After we iterate through the first record of the data set, now we're going to have all of the dates read in from a previous record. In that case, we will find that we do have that key for most of them. In that case, we want to update the contents of that map entry to contain its old value plus the new count for the new state that we're reading in from Australia or other areas in the data set. So we're going to say count by date set under the same key, but now we're going to fish out the old value. We're going to run the get method, which corresponds to the set method, on the same key and then add the value to it, and that's what we're going to store in the key. By the time we do this doubly nested iteration, we're going to have in this counts by date map a mapping from the individual date strings to the total count for all of the rows in that particular array. Let's take a look at how we're going to invoke this aggregate country function. Here at the end of this block, we've got a return statement that's going to basically give back the data that we inspected up here, this tidied up data that has samples for each country and each date. In order to get at that information, we're going to have to pass in to the aggregate country function information for each of the countries, and that brings us back to this group by function that we inspected before that takes the raw data from the internet, groups it according to the country. And this is being used inside an invocation of a function called flat map. This is also coming from Lodash. And this is a type of map function, but let me come back to that in a second. So just like the map functions that we've been seeing so far, the first argument is going to be basically the list of things that we're going to iterate over. And the second argument is going to be the function that we're going to invoke for each of those things. So the group by gives us the data that looks like this, and then because this is at the top level, going to just be iterated over by the country names and then handing off the details for that country to the aggregate country function, that's exactly what we want to have happen here. So the map here does that job for us. Within this function then, so this is the data for a single country, say Australia, we're going to create that counts by date map by invoking the aggregate country function. Remember, this thing returns the counts by date map that we defined up here. We're also going to initialize a variable here that we're going to use to fill in the values for this tidied version of our data. So it's just an array. To iterate over the data that we got back from the aggregate country, what we want to do basically is create an entry for each country for each date and then the total value for the country on that date. Aggregate country has already taken care of folding up any multiple entries for a given country into a single total by date. And so what we can do here is just use the regular iterator over that counts by date map. Now it turns out that Lodash doesn't know how to iterate over maps. So here I'm using this built-in for each function, which is defined on a map. And what it's going to do is call a function that's going to be handed the value of each of the entries in the map and the corresponding key. So what it's going to do here is call this function that's going to receive for each of the elements in the map, the value of that element and the corresponding key. And what we're trying to do here is create an array that's going to look like this when we're all done. So the by country by day array is going to have added to it, just using the standard JavaScript push, an object that contains the country. So the country name we can get out of the country data itself. Then we're going to use the date, which is the key value of the map, and the count, which is the value element in the map. And notice here we're finally making use of that date parser function. So this key at this point is just a string that looks like a date. We want to turn that to an actual date, a JavaScript date object, and that's what the date parser does by invoking this parsing function that we defined up here. And at the end of this process then, the country by day information is going to be stored in this array, and we're going to return that. Remember that we're doing this all inside of a map function. So we're going to take the original data that came in from the internet that we've grouped by country and converting that into a list of the individual country, day, and count for that particular country. If we just used an ordinary map function, we would end up with an array from the map of arrays that correspond to these by country by day values. What flat map does is it takes and creates that array of arrays, but then it flattens it down into a single array. So instead of having a top level array that contains, say, only the values for Afghanistan, and then another element in that array that has only the values for the next country in the list, those lower level lists get folded into a single top level list that has all of the country data in the entire data set. So now that we have a tidy data set, we're ready to do some visualization. Here's what we're going to end up with: a chart that shows all the countries. There's a lot of them, so they get chopped off here by the Vega-Lite tool. On the vertical axis, I've got the number of confirmed cases per country, and on the horizontal axis, I've got the dates for the data sets. And I've also created a drop-down list here of all of the countries in the list. So you can choose the country that you want to highlight. Let's open up the code for this. And we can see that it's basically just a collection of invocations of standard functions that are defined in the Vega-Lite API. First of all, we want to create this country selector. It's going to just be a drop-down list with all those countries. This was the purpose of creating that sorted list of all the unique country names. So we're going to create a new object called country selector, and VL here is Vega-Lite. We imported that down here, import Vega-Lite from this other observable page in order to have access to that API. So everything here starts kind of with an invocation of a method defined inside of Vega-Lite. In this case, we're creating a selector. We want to allow only a single value to be selected at once. There's also a select that lets you do multiple ones. This select string just kind of gives you a little prefix on the label that's associated with that dropdown. Then this fields method tells it which of the values from the set of data that's being graphed are we interested in displaying in this list. And we want to get the country element. That basically corresponds to this key in all of the tidied up data. We're going to initialize this so that its initial value is the US. So when you reload the page from scratch, you see US data. And then we're going to bind to that a control called menu, which is basically this drop-down menu, and we're going to populate that menu with the list of countries. So that's why when we open this guy up, it's got the country list in it. So that's basically just setting up this country selector, and it's done as a separate operation, invoking the top-level Vega-Lite object to have access to all of that functionality. The visualization itself is actually this whole second piece. So the return value from this block is going to be this chart and the associated control. What we're doing here is using a series of Vega-Lite API calls to configure the Vega-Lite object that's going to be handed off to the runtime and display our chart. So we're going to use a point type of mark. We can use bars and boxes and all sorts of other things, circles, and we're going to enable the tooltip for each of those points. And we can see that when we go up here and hover, we get the date, the confirmed value, and the country that we're looking at. Here's information for the US, here's information for Italy, there's stuff from Iran, France, China, and so forth. So this tooltip property configures the points that we're using in our chart to have information about the source of the data that's being displayed at that point. We have to tell Vega-Lite which data we're going to use, and we're just using the tidy data. And that was what we returned from this cell up here, tidy equals, and then that whole thing. So it's basically the return value from that flat map, and that's what is going to be used for the display. We can alter the height and the width of the chart, and that's what I'm doing here. This is in units of pixels. And then we're going to set up a selector in the chart based on this selector that we've defined up here. So we're just passing that country selector directly in here. The majority of the functionality when we're configuring a Vega-Lite visualization is this encoding. Basically, the encoding maps entries from our data set to characteristics of the resulting chart. And each of these things, again, is a top-level invocation of something from Vega-Lite, and we're just going to pass multiple of these encodings into the encode function. So that starts up here and it ends down here, and you can see that each of these guys is separated from one another by a comma. So first of all, we're going to configure the position of each of these marks along the x-axis. We're going to use the date field from our original data set. So back up here in the tidy data, as we saw before, we've got country, date, and count. And we want to have the x-axis show the date. So we say field and then date. There's actually an ordinary field with no decorator here that is a generic field type. And you can supply additional information to configure that, but there's shortcuts for common cases. So when we use field T, we're telling Vega-Lite to expect there to be some date or time information in the field of the data that corresponds to the property name date. And then we can also affect the title that's going to be displayed in the chart. So this capital D date is what shows up because we're specifying that explicitly, and we can call this anything we want. If we don't include the title, then I think it just falls back to the name of the field. So that specifies where the mark is going to show up along the x-axis. Then we're also going to do a similar thing along the y-axis. The difference here is that we're going to get the number of confirmed cases, except we're going to fish out the count property from each of the objects in the data list. And this is using field Q, which stands for quantity or quantified or something like that, basically just telling us that we want to use count as a quantity instead of a date value. We can also configure, just like we can set the X and the Y position of each of these marks, we can also give the mark additional properties. In this case, I'm encoding the country as a color for each of the lines. And that's done similarly. So instead of saying I want to configure X or Y, I want to now configure the color. And for that color value, I want to use something associated with a country. So field N is a way of specifying a nominal field, which basically just says we've got a name that I want to encode, and Vega-Lite chooses some colors that allow us to distinguish one from the other. And we're going to give it a title that shows up, in this case, at the top of all the different country names. And then finally, I'm using this country selector. So if I go back up here and choose, so I've got Italy is being displayed here, and the highlighted marks are from Italy, we can see from the tooltip. But if I go back and say choose the United States, it's going to focus our attention on a different portion of this chart. We still see all the other countries with sort of a dim opacity, but the one that stands out is the one that we've selected from this list. So we're using a different encoding. Instead of the position or the color of the mark, we're actually specifying the opacity, so that sort of the transparency of that underlying mark. And the opacity is basically being set if the country selector is selecting the country that we're looking at, we're going to have an opacity value of 0.95. And if not, the default value, if we're not selecting that country, is going to be 0.15. So that's why the opacity of these entries in the chart is much lower than the opacity of the currently selected country. You notice that there's a bunch of dots here down at the bottom that also look like they have a higher opacity. That's only because for many other countries that are in these data, they're kind of overlapping each other, and the combined total of all of their lowered opacities gives us something that looks like the overall opacity is higher. Then the final thing that we invoke on this top level Vega-Lite object is a function called render that basically says, go ahead and do all this stuff and turn it into a graph. And that brings us down to the appendix section, which is where we had all these kind of declarations, and completes our tour of this particular visualization.